Hey, good day, everyone. Welcome to the session. We still have 15 minutes and we would be starting at sharp 8:30 IST. So, in case you want to introduce yourself, please go ahead and do that on the chat. The session would be starting in next 15 minutes. Today, we would be discussing about Kubernetes networking. And there is a follow-up webinar as well happening on September 14th, which would be with respect to securing your network. So both are network topics. Today would be networking basics, and the next one would be with respect to security aspect of it. So go ahead and let us know in case you're already certified in Kubernetes or you're planning to do, you're working in containers, or you're new to container world itself. If you want to transform your career to containers, what exactly has brought you here on our webinar? Please go ahead and share your feelings with us or thought with us. We'll be starting sharp at 8:30. It's like 14 minutes from now, we would be starting. So hey guys, welcome. Thanks for joining us today. We still have around 13 minutes in hand, so we are waiting for others to join in. The session would be starting in next 13 minutes. Please go ahead and introduce yourself. Tell us what has brought you here in our session, and are you interested in doing Kubernetes certification, or you're starting a journey on containers? What exactly is your plan for the future? To share that story with us. We would love to be part of your success story as well. Thanks for introducing yourself, guys. In case you have joined now, we would be starting in next 12 minutes. Please go ahead and introduce yourself to the entire group. And hope you guys are connected with us on LinkedIn. We have a tech scalable page in which we keep doing a lot of webinars like this, contributing back to the community. So you can become a member of our page and you can get to know about our upcoming webinars as well. I'll be giving you a data about what all webinars are upcoming as well at the end of the session. So stay tuned for that too. Hello, everyone. Thanks for joining us today. We have 10 more minutes. We would be starting sharp at 8:30 India time. Please go ahead and introduce yourself to the entire group and do share your story, what exactly you do, what background you work in, what exactly you're looking for in this session, what has brought you here in our webinar. If you can share those details, we would love to know that. So I'm also going on mute. I'll be right back in 10 minutes. I'll just grab a cup of coffee and be back. So please join and introduce yourself. We will be starting sharp at 8:30 India time. That's around 14 minutes from, like not even 14, I'd say 9 minutes from now. Hey everyone, thanks for joining in. We would be starting in another 6 minutes. So the session would start at sharp 8:30 IST, India time. Meanwhile, you can introduce yourself, tell us about what you work on. Are you already into containers? You're using Kubernetes, or you're using any other containerization tool or orchestration tool? Tell us about that so that we get to know you better. And meanwhile, we'll wait for others to join in as well. Okay, thank you everyone for joining in. We would be starting in another 3 to 4 minutes. We are just, our right time to start is at 8:30, so we will wait for 8:30 and then we would begin our session. Meanwhile, go ahead and introduce yourself, what exactly you're looking for in this session, what has brought you here. And if you know Tech Scalable from before, you have attended our webinars, are you people liking it? Any future topics which you like us to deliver, you can also give us suggestions. Thank you. Thanks for introducing yourself. Hello, everyone. Team is there at the back end as well. In case we have any questions for us, you can even post that. And we have seen in the past that LinkedIn video quality drops a bit. So you have the YouTube link on the chat. You can also log into the YouTube link. In YouTube, the quality doesn't drop. So if you're feeling any lag in the video or it's getting stuck, you can also see the live on YouTube. So I think we are good to start. Let me just check if Kopal can do the introduction. She was facing some network issues. Cool, then I'll start with the introduction of the session myself. So we are doing a two-series Kubernetes webinar. The first one is today and the second one would be on September 14th as shown on the screen. Today we would be discussing about Kubernetes networking, and September 14th we would be discussing about securing our network with help of network policies. So they are both related. So it's good if you attend them in a series. Just to introduce ourselves, we are Tech Scalable. We provide services across training and consulting. We focus on varied niche technologies like cloud. We work in AWS, Azure, Google, Oracle, all the clouds. We are focused on DevOps. We do standalone open source DevOps plus cloud DevOps as well. Machine learning, data science, and AI is something we are doing these days. So we provide consulting services for companies. We help them implement their stuffs. We audit their infrastructures. We provide them improvement points for security aspects, or we help them migrate to containers and move them to Kubernetes as well. So that was about us. Now, speaker for today's session is Me, Mamta. I am co-founder at Tech Scalable. I have been in this industry for around 17 years. I started my journey with a CC as a CC++ developer with Alcatel-Lucent, and I started my cloud journey 9 years back with OpenStack, a private cloud, and then saw that there was not that much of traction in the market with respect to, say, private cloud, and that's the reason moved out slowly to AWS, got certified into that, then moved on to DevOps because I was missing the coding touch of it and started to work on Ansible, Chef, Puppet, Kubernetes, containers. Containers is something I was working on before moving to cloud itself, but it was Linux containers. I'm a Red Hat certified instructor and a Microsoft certified instructor as well. So let me see if I have today's agenda. I didn't think so. I don't have that slide ready. So let me take you to the LinkedIn page itself and show you what's the today's agenda. So let's see today's agenda. Today we would be discussing about the containers networking first. Then we would move on to Kubernetes networking. We would discuss about how pod-to-pod communication would happen if pods are residing on the same host. Then we would look for inter-host communication. We would also check how a service, or what's the need of a service, rather, I would say. Even if we have a pod's IP address, why we would need service to intercept in between and do the communication on its behalf. So different types of services are there in Kubernetes that we would touch upon. And then finally, we would be closing that with Ingress Controller. So not too much of hands-on today, rather too much of understanding, I would say. We need to understand the networking. So what I have done, I have created pictures like this picked up from the internet, and I'll explain these diagrams so that we understand better about the different types of networking. So this particular picture depicts Docker networking, the networking on a Docker host. This is Docker host networking. So the host machine on which Docker is installed is called as Docker host machine. By default, a bridge called as Docker 0 bridge gets created. That's the default bridge network. If you want to create your own bridge network, you can create a custom bridge network like this, my bridge. This is a custom bridge network. Bridge is connected to the Ethernet interface of your host machine. This is my host Ethernet interface. So there are two namespaces, or rather I'll say two network namespace. Namespace. Okay, yeah. So this is host's network namespace. And this is for the container. Container would have its own Ethernet interface. So it has its own network namespace. And that's the reason it gets its own IP address. A network stack is there for each of the container in case of Docker. Bridge has a subnet. And in that subnet, like 172.19.0.0/16 is the subnet of the bridge. And that's the reason this container has got .2 IP address and this container has got .3 IP address. Both of them are having a Ethernet pair residing on the bridge here. So this is the Ethernet pair on the container, and there would be a pair of that same Ethernet interface on the bridge as well. So these are all virtual Ethernet interfaces. They are all virtual. This Ethernet interface is of the host. So if my containers want to communicate from one container to another container residing on the same network, it's pretty simple. The packet originating from here would have destination of 172.19.0.3, and the packet would fall on the bridge. Bridge would look whose IP address is that, and it will go ahead and send the packet to the other container. Same way, the communication back also happens the same way. So in the same network, containers can communicate with each other. They don't have any trouble translating the IP addresses. But one more thing, these IPs are private IP addresses. They are not accessible from outside. So if you want an external connectivity, like my user sitting outside wants to communicate to the web application from the outside world, he or she can't reach on 172.19.0.3. And that is when we come with the concept of host port. We come with the concept of host port. Host port means that you grab a port number on the host, like port number 8000, and you say that whenever packet comes to port number 8000, that would get routed to the container on port number 5000. You're stitching up a connectivity. How do you do that? When you create a container using Docker run command, you are specifying how you're creating the container and you specify -p. Here you give the host port and you say :container port. Then you give the name of the container, you give the process which you want to start. So you're saying that I am tied up to port number 8000 on the host and my container application is listening on port number 5000. So this 5000 is something which is configured on the application level. So you are not going to change that. Like for example, I am running this container, port number 8000 on my host machine is empty. I can use this. Say for example, Shivam wants to run the same container and I've given him the image of the container. In his host machine, the Docker host, port number 8000 is booked by another application. He may tag that to port number 8001. Then his host port number would be 8001 rather than of 8000. But on the container side, the port number is going to remain the same, which is 5000. It is not going to change because application has been configured in a way to listen to port number 5000. So we are grabbing a port number on the host and we are tagging that to one of the containers. And I'm saying that my web container is going to listen on port number 8000 on the host machine. It is also called as port forwarding. It is also called as port forwarding. So how does that happen? The user would send the packet to VM IP address on port number 8000. It will fall on the bridge and then it would get routed to the container IP address on container port number 5000. So this is the way it would get routed. So when we are grabbing a port number like this, actually an IP table rule has been written. IP table rule gets written that this is how you're going to forward the packet. Packet coming on 8000 would be forwarded to the bridge, and from there it would be routed to the container IP on port number 5000. And that's how you can get an external connectivity to a container, which is having a private IP address. Our containers are always having a private IP address. They can't grab a public IP address. So this is containers networking. Container to container networking within a network or connecting to a container from outside the host machine itself, external communication, you can say. This is how it happens. So bridge is the default way of communicating. As soon as you have Docker deployed in that host machine, a default bridge network gets created called as Docker 0. If we want to create our own custom bridge, we can go ahead and create a custom bridge with Docker network create command, and we can have the bridge network. Any container getting created on that network would grab the IP address or get an IP address from the subnet range of that particular network or the bridge network, I would say. So this is all about the Docker networking. Let's see how does the Kubernetes networking behave, because when we are having too many Docker host machines or too many hosts which are running containerization platform, how that container to container connectivity can get stitched up. So let's see the Kubernetes networking part. In Kubernetes, what happens, there would be several host machines which actually would be running containers inside that. And we know that containers are wrapped up by a pod. In Kubernetes, pod is the smallest unit of deployment, and pod gets an IP address. Let me try picturizing that for you. So in case of Docker, containers had the IP address, but in case of Kubernetes, it would be the pod which will get an IP address. So pod has a network namespace rather than the container. Let's draw two pods in here on the host machine. So this is my pod A, and for example, this is my pod B. Okay, cool. So this is pod A, and this is pod B. There is a bridge network. So let me draw a bridge from wherein they would get the IP address. So every pod which is hosted on a host machine gets an IP address from a specific range. Like for this host machine, the pod IP address range is set to 10.1.1.0, for example. In the another node, it would be 10.1.2.0, that sort of thing. So whatever IPs are assigned to this pod, they would be residing in this range. Like this would get 10.1.1.3, this would get 10.1.1.4, for example. So a Ethernet interface here, and on this bridge network, you would be having a Ethernet interface pair of it to which it is connected. So this is the Ethernet interface of your pod. And container is residing somewhere underneath it, like container C1. This pod also can have container C1. This is the Ethernet interface of your pod B, and it would be connected to this on, say, the bridge. And this bridge is connected to the Ethernet interface of the host machine, which is ETH0 of the host. So this would be your Linux network. This is your Linux network. This IP address range is fixed on a specific node. If I have a similar node like this, let me just try selecting this. So these are two different nodes in the cluster. Erasing this. Okay. Yeah. Now I have a network running which is connecting both these nodes, right? There would be a network which would be obviously connecting both these nodes. As such, the host machines are connected to this network. Like if I'm using Azure, this is my VNet. If I'm using, say, AWS, that's my VPC. So the network which is there, within a network, I could have a subnet and all that. So this is that external network to which our host machines are connected. So this can be called as my node 1, the worker node 1, and this is my worker node 2. The IP address range on this node would be different. It would not be 10.1.1. range. It would be different. Let me just first just put the boxes correct. And here it is 10.1.1.0. 10.1.2.0, and this guy gets an IP address 10.1. Say 2.3 and 10.1.2.4. Now imagine this is pod C and this is pod D. Let's rename them. When pod A wants to communicate to pod C, it would send a packet whose source is 10.1.1.3 and destination is 10.1.2.3. So what happens when the packet originates and it comes to the bridge? Bridge looks at the packet and understands that the packet is not residing on this node. So it has to send the packet out. And for that, we would need a interceptor or one who can switch the packet or route the packet. So dependent on what type of networking you choose here, like few people look for L2 networking, few people look for L3 networking, dependent on the CNI interface, which type of CNI plugin which we are using, the routing would differ. The routing is going to differ in that case. Like, for example, there are some common CNIs which are used, CNIs which are normally used. Flannel is the very basic type of CNI plugin which is used. People use Calico, people use WeaveNet. There are a lot of different types of network plugins which are there in the market, and people use that particular plugin so that the routing can happen and the node-to-node connectivity or pod-to-pod connectivity in different hosts can happen. If the packet is originating with a destination IP address of 10.1.1.4, nothing has to be done. It's on the same network, on the same bridge, the packet would get routed. The question is when the packet has to go out and it has to reach the other pod, which is not residing on the same node, then what we do? So there is one CNI pod running in every node in the cluster. There is one CNI pod running in every node in the cluster, which takes the responsibility of routing. And that particular pod, like, it intercepts and it changes the source and the destination and makes sure the packet travels to the correct destination. That's the work of it. So let me show you the Flannel one. I have picked up a good picture from the internet, which has the Flannel. Yeah, so this is the one for the Flannel. You can see here. Let me pick up a color which would be visible in this. Yeah. So this is my pod, this is my pod, this is my pod, this is my pod. This is the bridge network from which the containers would get an IP address. If the source is 1096.1.2 and the destination is 1096.2.3, how does the packet travel? The packet would come to the bridge, and from there the Flannel would intercept. The CNI pod would intercept the packet and it would go ahead and change this. Encapsulation would be there. So source and destination, this packet is there. On top of it, there is one more encapsulation done. You can see here, the source and the destinations are changed. Source is this host machine's IP address and destination is this server's IP address. You can see here, .102 is this and .98 is this. It understands that the packet is not destined for a pod which is residing on the same host machine. So it has to route the packet out. And that's the reason this encapsulation happens. The source and the destination is changed and the packet is transmitted out. You can see here, this is my green original packet. A header is attached on top of it and the packet is sent out. So from here to here, when the packet is traveling, it is like inter-node connectivity. It doesn't understand the packet is actually destined for a pod and not for a host machine. Packet arrives here. Again, this Flannel takes the responsibility of it. It would remove that header which has been attached. So this will get removed off and you're just left with this green color original packet in which the source is this and destination is this. Looking at that, obviously the routing is pretty much simple. You can send the packet to that particular container, or rather I would say pod, which is having the destination IP address of 2.3. And that's how the packet would get routed. So this routing is one of the simplest way of routing. And this is how most of the CNI plugins do. In every CNI plugin, there would be a CNI pod, dedicated pod running in every node in the cluster whose responsibility is to pick up. And depending on what type of protocol they are using or encapsulation they are using, someone would use VXLAN, someone would use BGP, someone would use normal VLAN type of protocol, and they would try to encapsulate and send that packet further. So that's how the inter-host pod-to-pod communication happens in case of Kubernetes. This was the Flannel example. Like, I'll just name it on the top so that you people can just understand. This is the Flannel way of doing it. Now, there is one more famous CNI, which is called as Calico. Let me have that as well. Yep. So some good sketches from the internet, which has explained well. I've picked them that. And I'm trying to explain from there because, again, sitting, drawing these things in such a beautiful way, it takes a huge amount of time. So this is my worker node 1. This is my worker node 2. This is pod A. This is pod B. This is pod C. This is pod D. So 2 pods on worker node 2, 2 pods on worker node 1, everyone having their own Ethernet interfaces. You can see here it says network namespace. Every pod has a dedicated network namespace. And these are the Ethernet interfaces of theirs. Like, it gets auto-generated numbers like this. In Calico, the Ethernet pair would have a name of this sort. So this is the Ethernet pair, and this would be the Linux networking, the host network namespace. If the packet has to travel this way, it's well and good. It would travel from one pod to another pod on the same network. That would happen. In case it has to go outside, here you get a VXLAN IP to IP type of encapsulation done. And this router will go and look into that CNI pod and will try and translate it. So packet would be coming from here. It will go to this. It will understand it's not destined for this specific node. So here the source and the destination would be changed. How we saw that source and destination got changed in case of Flannel, the same way the source and destination would be changed, and the packet would reach this node. And after that, it would reach this. And here again, you would have that VXLAN residing, which will go ahead and intercept the packet, and rather I'll say it doesn't go on this path. So I'm just changing that. So it would send it here, and if it is destined for pod C, it will go to pod C. So this would be the path like this. The packet would be going from here to the outside world, or rather on that network. And then it would get routed from here and it would go to that particular pod. So this is the pod-to-pod networking. Depending on what type of CNI plugin we use, this encapsulation and the way we route the packet changes from one CNI plugin to another CNI plugin. So this is the pod-to-pod connectivity, but if they are residing on a different set of host machines. Next, let's see what exactly is a service and why service comes into picture. If we are able to route the packet with pod's IP address, why we would not do that and why we would need service to come into picture? What are the drawbacks if we are routing with pod's IP address. That is important to understand. That we would go ahead and learn. So let me just take out a clean slate to draw something. Let me pick up a blank slate to draw. So we know that pod has an IP address, and we also know that pod doesn't have a static IP address. So pod's container will get a port number, and pod has an IP address. So pod has the network namespace. This is my pod A, which is having container C1. Container C1 can listen on port number 80. So I would be reaching my application on pod's IP address on container's port. That is how the communication happens. But this IP address is not static, it is dynamic in nature. And we know pods are not as stable as virtual machines. So if something goes wrong, kubelet goes and cleans up that particular pod, or it restarts that particular pod. The IP address changes at that point in time. I may reside in the same node in the cluster and get an IP address from the same subnet range, but I may not get the same IP address. Or it could be that I don't get the same node as well. If creation is triggered, pod got cleaned up, and because of that, the controller is asking for the creation of a self-healed pod. Pod A got deleted. Now controller is creating a replacement pod, say pod A dash. It would have the same set, like container would listen on port number 80, but you can't guarantee that if pod A was hosted on worker node, say 1, this may get hosted on worker node 2. It entirely depends on the load which is there on that node in the entire cluster, right? Scheduler will take a call. So this IP is not static. Now imagine that pod B is communicating to pod A. If the IP is going to change every now and then, it becomes difficult. Yes, we have a DNS pod whose work is to do the DNS translation. If you give the name of the pod, it will give the name of the give the IP address of the pod. But imagine these many entries going written, removed, and all that. It becomes very difficult. And if I have two pods, these are both replicas. These are both replicas. When pod B is sending packet, someone should be there in between to take up that packet, like the load balancer, and then route some percentage of the traffic here and some percentage of the traffic here, like 50-50 division. That also needs to be done. So we bring in a concept called a service. Service is nothing but a static IP which we grab from a service IP address range. And we just say that instead of sending the packet to pod A or pod A dash, you send the packet to service. And this IP address is a static IP address. It's a static IP address. Because this IP address is a static IP address, pod B is not going to struggle every time finding out the IP address to the DNS name to the IP address translation, right? So service will get an DNS entry, like the name of the service, dot the namespace in which it is created, then cluster.local, service.cluster.local, a string gets attached at the end. So if I have a service A in default namespace, my service DNS name would be service A dot default. Service.cluster.local, that string would get attached. So when the packet is sent, the packet is having destination of the service rather than the pod. Service will receive the packet, and service responsibility is to make sure that both the pods get the packet. So service needs to have the backend pool created. So backend, it is called as backend endpoint list. backend endpoint list is there. This endpoint list is populated with the help of label and selector. Service is selecting the label of the pod. Suppose I've created pod A with label as app equals to A. Replica will also have the same label. Your label is app equals to A. And your service will specify that I have a selector whose work is to select a label which is app equals to A. So all the pods in the cluster which are having label as app equals to A would be chosen, and here their IP addresses would be populated. So here pod A's IP address is populated and pod A dash's IP address is populated. Now when the packet is arriving, one time it would send here, one time it would send here. This would be handled on the Linux level, the IP table rule or IPv6. There are different modes in which it works. Kubeproxy takes that responsibility of updating that IP table rule. So service is like a virtual entity, okay? It actually doesn't exist. It's nothing but the IP table rules which are written by the kubeproxy. And that on the Linux level, on the IP table level, the load balancing is also happening. Few packets would go to pod A, few packets would go to pod A dash. So our destination from the client is this, but here the packets would be forwarded to the correct pods just with the help of label and selector. Now pod A is residing within the cluster, so the traffic which is coming, it is internal traffic. So let me just save this. So when we are creating a service, like I'll just compare that with the load balancer, how we have, if you have virtual machines and you don't get IP addresses for the virtual machines, you don't give external IP addresses. You get a load balancer which will have external IP, and anyone trying to access your application from outside reaches the load balancer's public IP address, and load balancer has that backend pool for distributing the traffic in a round robin fashion across the virtual machines, right? These are layer 4 or network load balancers or the normal standard load balancers. So this work is done by a load balancer. So service does load balancing, service does health check. It checks the health of the pods behind it. If pods are not there, it would remove those entries as well. Like load balancers also does a probing, right? Here you can configure probing and you can make sure that if pods are healthy, then only the entries are existing in the endpoint list. And if pods are not existing, entries would be removed immediately. Who takes up this responsibility? Kubeproxy takes this responsibility of adding the entries and removing the entries. Now, instead of getting a traffic from outside, when I get a traffic from inside client, a client is there who is accessing my application from inside. This is nothing but an internal load balancer, a load balancer which has an internal IP address, right? So internal to a cluster in Kubernetes is called as cluster IP. There's nothing called as private IP. It is called as cluster IP. So pod A will have its own service A, and there would be pod B, which will have its own service B. And when pod B communicates to pod A, the packet would be sent to service A. Service A has populated the endpoint list with the help of label and selector, and it would route that to pod A. If I have more than one replica of pod A, it would do load balancing of the traffic which is coming. When pod A is responding, the packet goes from, rather it would go directly from pod A, it will go to service B, and from service B, it would be routed to pod B. So this is not correct. Let me pick up the eraser. Yeah. So this is how it would be. So here the pod will send the packet to the service and service is going and forwarding the packet to the pod. So here selector is there, here label is there, and you have the destination always as the service because we have a static IP address for this. A pod may go up and down. Service is not like that. Service is not like a running process that it will go down and lose its network stack. It's just a static IP you have grabbed from a range and you're saying that, hey, Mamta, if you want to communicate to my application, please go ahead and use this IP address going forward. Within the cluster, if communications are there, service will have a cluster IP address, a IP address which is resolvable within the cluster. That's nothing but a cluster IP. Let me show you a few things on the cluster as well. So kubectl get nodes, if we see, this is my cluster, which I've just picked up 3 virtual machines in Azure and I've done a KubeADM cluster setup. It's running version 1.20 of Kubernetes, and there are 3 nodes in my cluster. One is master and 2 are the worker nodes. We had discussed that there would be a CNI pod running in every node in the cluster. Let's see that as well. kubectl get all -n kube-system. These pods run in kube system namespaces. If you can see, this is the WeaveNet plugin. How we discussed about Flannel and Calico, here the plugin name is WeaveNet. We have used WeaveNet plugin. One WeaveNet plugin is running in every node in the cluster. Even on the master, containers are running. The containers or the pod, rather, I would say the API server pod, the controller pod, the kube proxy pod, those are also running on the master nodes, right? They also need the communication to happen, and that is the reason WeaveNet would run one in every node in the cluster, including the master nodes. Now you can see core DNS is there. This guy does the DNS translation. We have 2 replicas of it running for high availability. There are 2 instances of the core DNS running. And in every node, we have kube proxy. This guy takes the responsibility of adding those entries in the IP table and all so that the routing can happen properly. So whenever a pod is created, service is created, all those entries are being written by kube proxy. Now, these are the things which are running on the cluster by default. When we bring up our cluster, these processes comes up just to bring up. This is as part of the initiation of the cluster, right? WeaveNet will not be there, dependent on what type of plugin you are planning to deploy. That is when you choose a plugin and you apply that plugin and that plugin comes up. I've chosen WeaveNet as my plugin and I've applied that plugin. Let me just clear the screen and come back. kubectl get all. If I try to see something on my default namespace, at present nothing is running. Let me see if I have a folder. Yes, I have a folder here which has a huge set of YAML files. I would try to create a dummy pod, and I want to show you if it is running on worker node 1, what IP it is getting, and if it is running on worker node 2, what IP address it would be getting. So I have a simple Nginx deployment YAML file. We normally use this when we have to deploy a Nginx pod, and I'm deploying 2 replicas of the pod. Let me make it as little bit higher in number so that we get more pods and we can see the IPs. So I'm saying create a deployment controller, and that in turn is going to create a replica set and 4 set of pods. Pods template is here. All the pods would be look alike. They are all replicas. They will come up with the same label. They will have same specification of the container running, and container is listening on port number 80. Let's go ahead and create this. So I would say kubectl create -f, and I would give the name of the file using which the resource is to be created. I will do get all and see. 4 pods are up and running, and deployment controller is there, which is expecting 4 replicas to run, and this is the replica set. So in case you have you are new to Kubernetes or something, then you can go to our tech scalables page and look at previous webinars. In that, we have explained what is a deployment controller, what is a replica set and all. Today, we are just focused on networking. So we are more focused on looking at the IP addresses of this pod. So if I do get pods, I will not get the IP address. But if I want to look at as a wider output, more details about it, you would see there is a IP associated to it. 3 of the pods are hosted on worker node 2, and 1 of the pod is hosted on worker node 1. And if you look here, worker node 1's pod is having a different IP address range, and worker node 2's pod are having a different IP address range. If I go ahead and scale it, let me just do a scaling. I can go ahead and scale by just changing the number of replicas here. I don't have a horizontal pod autoscaler at present, so I'm just changing this replica number. And I'll go ahead and say kubectl apply -f. This resource is already created. I'm just applying the delta changes. Changes are applied. Don't go by that warning. Changes are applied. Let's do kubectl get all, or directly do pod -o. So 1, 2, 3, and 4 are running on worker node 2. Everyone is having 1032 IP address range. 4 of them are having 1040 IP address range. So we had discussed that the subnet ranges of the pods IP addresses would be different on different nodes. And that is the reason it is able to grab the IP addresses for the pod from that particular range of IP. All pods residing in worker node 1 will always have 10.40 range. All pods residing in worker node 2 will have 1032 IP address range. These are all non-static IP addresses. That means if I go ahead and kill a pod, let's go ahead and delete a pod intentionally. Same pod can't be bought back, okay? It's not bringing up the same pod. In containers, it's always self-healing. Recreation would happen. A new pod would come as a replacement of it. So if I'm deleting this pod, I'll just press Control-C. The instruction is being given. You can go ahead and see that this guy is terminating, and 81, or rather 5 seconds back, this has come up. So one pod got deleted. This was the pod which got deleted. This IP address got freed, and the IP address could grab the same. The pod name is different here. You can't guarantee that the IP would remain the same because the IP address got freed. That was the first IP address, free IP address in the pool. So that IP was picked up, but that can't be guaranteed that that would be the IP address always allocated to it. So we understand that pod, when it is getting deleted, the entire stack is also getting cleaned up. And that's the reason you can't have static IP address assigned to a pod. So now let's see. What do? We will create a service corresponding to it, and we will try to expose this application with the help of service. So let me cat my Nginx deployment file once. My label is app Nginx. So I have an Nginx service file, but that is not correctly written intentionally. And that's the reason I want to change this. So I'm creating a service called as my service, whose work is to select pods which are labeled as app Nginx. It will receive packet on 80, and it will transmit the packet to containers port 80. So service also has an IP and a port combination and should transmit the packet to the pod's IP address and containers port combination. If container is listening on 80, I'm sending the packet on 82. Container would not ever receive the packet, right? That's the reason the port numbers are also important. Let's go ahead and create this kubectl create -f and give the file name. Let's create the service. At present, there are 8 pods at the back end. So we should have multiple IP addresses in the service endpoint list. Let's see that. Kubectl get svc. And you see this service is there. service called as My Service, which has an IP address of 10.102.206.235. This IP address range is entirely different. When you're setting up the Kubadium cluster, you can give your pod's IP address range. You can also provide input for your service IP address range. So there is a service IP address separate range from where whenever I'm creating a service, a IP address is being grabbed. So this is the service IP address. And I'm on my master node. At present, if you see, I'm logged into my node 000 itself. I've configured my kubectl here itself. So if I try to curl on this IP address, it should be resolvable because master is also part of the cluster and cluster IP address is resolvable. I want to describe the service and show you. I think the name of the service was My Service, if I'm not wrong. You can see this. The service name is My Service. It is belonging to default namespace. The selector, it is doing selecting for the pod, and this is the type of cluster IP. And that's the reason it has just grabbed a IP address, which is only resolvable within the cluster. And these are the list of the IPs of the containers, which are there as the backend for this service. So service is having 3 plus 5, totally 8 IPs at the backend. And now when I try to reach my application doing curl, it is actually distributing. It would distribute the traffic across different pods. It would do a round robin distribution of the traffic. So this is what service is. Now, even if the pod is going down, no matter what it is, like I go ahead and delete a pod. I'll go ahead and scale the pod to a very smaller number. Let's do that. Let me go ahead and clear the screen once again and open my Nginx deployment file and make the number of replicas to 2. So what would happen? Out of the 8, only 2 replicas would be retained and 6 of them would be cleaned up. When the pods are deleted, the service would also have the endpoint IPs erased from there. Kubeproxy takes that responsibility. Those entries will go off, the service endpoint list entries. So let's go ahead and apply these changes. Just changing the file would not suffice because we have changed the file. We have not applied the changes. Okay, cool. So changes are applied. Let's do get pods -o wide ones. All are terminating. Only this and this are running. One is 1040 pod and one is 1032 pod. If I look at the service now, let's see how does that look. There are only 2 IP addresses. So for the client, things are not changing. Client is always communicating on this IP. Whether there are 2 IPs at the backend, whether there are 8 IPs at the backend, what are their IP addresses, it is least bothered about, right? So that helps us in making sure that one static endpoint is there to which you can communicate, and that is not going to change anything for you in case it's going down and all that stuff. So that's the beauty of service. This service is ClusterIP, just has a cluster IP address with it. There are other types of services as well that we would see next. So just to show you what we discussed, here was our web Nginx application or the WebEx application. It had a service of its own. We have not seen what type of service we would make for this. It's normally when we have a database type of application or an app or a microservice which we don't want to expose outside the cluster. For that, we make the ClusterIP type of service. This ClusterIP, if you see here, we have made it for Redis application. There are 3 Redis replicas and this service is serving the Redis application. You can see the label here and the selector here matching. So let me pick up the pen. So this would be ClusterIP because this Redis is not exposed outside. In case we want to expose Redis outside the cluster, then the way we create a service would be a bit different. So I'll just emphasize on the file which we had written. Here, the default type is mentioned as ClusterIP. So if you don't have a parameter type in your kind service type of YAML file, your type of service which gets created is by default ClusterIP. The selector is important, with which it really grabs the IPs of the pods which are working as the backend of it. That is important. And the port numbers are also important. The port number on which it would be receiving the packet and the port number on which it would forward the packet. The parameter with port is service port number, and the parameter with target port is the port number of the container on which it would forward the packet. Now, let's say if I want to expose my application outside the cluster, what do we do? So the web app, which is there, the Nginx application, the web server, that service which we are creating, that needs to be accessed by these set of users. And they are external to my cluster. So I create a service of NodePort type. When I say NodePort, let's take an analogy, right? Like if a virtual machine is created and I need a public IP address on it, does that mean that it will not have a private IP address? It's not that the way, right? So now imagine this service needs an external connectivity. So service will have a cluster IP plus service will grab a port number on the node. On the worker node, a port would be grabbed, and that port number would be reached by the clients, and then the packet gets forwarded to the service. Let's see how does this happen. So these set of users are trying to browse, say, xyz.com, then it routes them to the node, particular port number on that node. Okay, you can take the worker node's IP address and a specific port number. When you reach on that port number, automatically Kubernetes understands that the packet is destined for service of Nginx, and it sends the packet to it. If the packet reaches service of Nginx, we know how does the packet gets distributed to the service, to the pods of Nginx, right? That remains the same. It's just that the external connectivity which is there, that has become different, and that's the reason we need a port number on the host, or rather node, I would say. So in such type of service, the kind is service, no doubt in it, but the type is node port. So one port number on the node is picked up, and you have the backend connection with the help of label and selector. This is the port number you are asking on the node. You can even leave that on the Kubernetes to allocate a free port on the node. So this would be the external port number via which the external clients would reach us. This is service port number, and this is containers port number, and this is host port number or node port number. These are the parameters. So we need to pass on these things so that we would be able to go ahead and create service which would be having a connectivity from outside. So how do you create this? Let's see that. I can convert the same service. This is my web application. It's Nginx. It's not Redis. I can go ahead and create the same service or edit the same service to have type as NodePort as well. I had the service YAML file. Remember, we had written a Nginx svc.yaml file. In this, I don't have a parameter called as type or an attribute called as type. If I say type NodePort and save this, as I had said before as well, that if you are saving, the changes are not applying to the cluster, you will have to apply the delta changes to the cluster with kubectl apply. Let me give the file name. Okay, there is a typo. service is getting edited. Let's do kubectl get svc and see the difference. So you can see here, the type has changed to NodePort. It has a cluster IP address, but it also has a node port number of 30859. I didn't specify any node port number, so a port number which was empty was being given. And the port numbers are normally above 30,000, which Kubernetes allocates for this. Now, let's go ahead and describe our service. Let me pick up the name from here. There's a typo. Let me correct that. kubectl, L is missing. Okay, so you can see these are the pod IP addresses which are in the endpoint list, the backend. The node port is mentioned. The type is as node port, but cluster IP is also there. So let's try and understand how it works. So let me draw a node. Let me try to draw it correctly. Okay, this is better. And I can have a pod inside this. Let me replicate this and have another node. And say this is pod A. And this is pod B. Ethernet interface of your host machine. And this is the Ethernet interface of your host machine. This is worker node 1 and this is worker node 2. We know that CNI pod and a bridge, all those things would be existing. I'm not drawing that. We know how in the internal, in the node, things are getting routed. We want to understand how it happens from outside. So as we mentioned, service is nothing but the entries which are made by the kube proxy on the IP table rule level, right? So you create a service for pod A. So it, with the help of label and selector, it understands that service A, whenever it receives packet, it will go to pod A. But this time, service A is nothing but a node port type. And that is the reason you have grabbed a port number on the node machine. You have grabbed a port number on the node machine. Say 32,000 or 30,289, some number is the node port number. So this port number which we have grabbed, so there would be another rule as well. When your packet is received on VM IP address on 30289, then forward the packet to service A. And then this rule will, once this rule is met, this rule is checked, service A will route the packet to pod A. So a user sitting outside, a happy user, because he's able to reach our application, reaches this. For him, it would be like if he is accessing xyz.com, xyz.com is resolving to VM IP address and the node port. So his packet arrives here. When it arrives here, it checks this rule. It gets forwarded to service A. Service A says forward that to pod A. So the packet reaches pod A. Now pod A is residing in worker node 1. If pod A scales to multiple replicas and pod A is getting replicated, the second replica is getting replicated and pod A is present on worker node 2 as well. So this port number, is it only blocked on one specific node or it is blocked on all the nodes in the cluster? Answer to that is it would be blocked on every node in the cluster. Whether your replica is sitting there, not sitting there, doesn't matter. That means if your replicas are not present, pod A is not present on this node as well, that particular port number is blocked. So that tomorrow, if You're scaling as well. That particular port number is there for you. That port number is blocked on the entire cluster level. So your user can reach this node as well. And this rules which are written, they are written in every node in the cluster. I'll say VM1 IP 30289 or VM2 IPs, whichever it is, would forward that to service A, and service A would forward that to pod A. Now imagine if the packet reaches here. It says forward that to service A. Service IP address is known to us. From there, we know the pod IP address as well. Pod IP is not of this node's range. This node is having pod of 10.32.0.8, and this node is having 1040 range. So looking at the pod's IP address, the CNI pod understands that it is not destined for this particular node. So packet would be sent to this node. And that is how, or it would not be sent on this particular port number. Rather, it would be sent on the Ethernet interface. So let me draw this. And then the packet would be again checked. Packet arriving should be sent on the bridge and it would be reaching the pod. So this is like a mesh which is created. The port number which is allocated for external connectivity get blocked on every node in the cluster. It's just not a specific node. It is present on every node in the cluster. So let me show that to you. So this is the IP, so this is the node port number. Let me just grab the IP address of mine. I think the IP, okay. Let me grab the IP and come back on the screen. Just give me a minute. So I have multiple nodes, right? I'll pick up the node's IP address, which is worker node 1. And I would give the node port number 30859. Let's try this out. So this is my worker node 1's IP address, and this is 30859. Same way, I can reach my application on the worker node 2 with the same port number 30859. So application is reachable from outside. This is my laptop's web browser from where I'm able to access the application. And that is only possible because we have grabbed a port number on the host machine. So this is all about external connectivity. This is all about NodePort. This is a way of accessing your application from outside the cluster. So when we are working on cloud or when we are working on-prem, we don't want to share a node's IP address and a port number to the client. Doesn't look good, right? So what we do in that case, we go ahead and have say a load balancer created, and that load balancer would be forwarding the packet. So we would have a node port, but we would be having another component as well, the load balancer. So the cloud load balancer can be used in case I'm running my cluster in, say, Azure. I'll be using Azure standard load balancer, or if I'm working on AWS, I can have my AWS, the normal network load balancer that could be created. So I'm just trying to keep this thing a bit clean and tell you how exactly that would work. So my pod is running on worker node 1. We have a service associated to it, and that's the reason this entry is there. I'll just draw an analogy here. When you told cluster IP type of service, only cluster IP was allocated. When you told node port, a port number on the node plus the cluster IP was allocated, right? When you reach the node port, from there, it has to forward that to the service. Service has a cluster IP address and the service port combination. That is what it would get routed to, right? So VM's IP address on the node port would forward that to your service IP address on service port. This service IP address is what? This is a cluster IP address. Now I'm saying I can create a load balancer type of service so that I don't give to my customers a IP and a port number combination, which doesn't look good. So my customers would be reaching the load balancer. This is on the cloud. It's not part of your Kubernetes cluster. I'll say cloud LB. Or in case it is on-prem, then it is called as metal load balancer. My users sitting here, they would be reaching here. Load balancer's public IP address. So your xyz.com is resolving to LB's IP address. And this LB has a backend. Every load balancer has a backend pool. The backend pool of it is nothing but the VMs, the worker nodes on port number 30859. That's the backend. So this load balancer is just meant for pod A. This load balancer is just meant for pod A. When pod A packet comes, it goes to cloud load balancer A and it sends the packet to NodePort. And from here, it will go to the service. Service will send it to pod A, and that's the reason it would reach pod A. If it reaches here, the rules would be matched, and finally the packet would be sent to this, and the packet would be reaching on pod A. This connectivity would be stitched up. Now let's take an example that you are exposing your pod B also outside the cluster. Then you will have service B, which would be leading you to pod B. You will have a VM IP and a port number combination for B, which will lead you to the service B. So a port number, say 30956. So in both the nodes, 30956 is blocked for your pod B type of application. And if I want a load balancer for it, then it would be a separate load balancer, a cloud load balancer just for B application. Your users would be reaching this. This would have endpoints of this and this. And when packet arrives, looking at these rules, it would forward the packet to pod B. That is how it works. So this is load balancer type of service. You will have cluster IP, you will have NodePort, but you will also create a cloud load balancer or a metal load balancer who would be routing the packet to that particular NodePort. Let's see if we do it, how do we attain that? So I'll edit the same one. I'm not creating a new one. From NodePort type, I'll change that to a load balancer type. And I'll go ahead and save the changes and again apply the changes. A little bit lazy in typing the command, so just going ahead and there was a mistake in this, so let me correct that. You can see here the NodePort load balancer link is getting created. It is saying load balancer. At present, the load balancer's IP address is yet not reflected, but in some time you should see the load balancer's IP address as well. If you do kubectl get svc, It says pending. You can see this. It says pending. The load balancer is getting created in the cloud. There would be some amount of time needed for the communication to happen from your Kubernetes cluster to the cloud account, get that load balancer created, the stitching should happen, and then that would show up over here. So let's see, it is still showing pending. So after a while, we can come here and check the load balancer's IP address. Now going to the last topic of the day, which is nothing but the Ingress controller. Why Ingress controller will come into picture, that we need to understand. So imagine I have an application which is made up of, say, 170 microservices. But if I go ahead and expose out of that a 20 set of microservices, payment, notification, few of the microservices are needing external connectivity. Say my Kibana dashboard or Grafana dashboard, a lot of such mini applications are there, the microservices are there, which are needing external connectivity. Then in that case, do I really go ahead and create these mini load balancers? Answer is no. Then at that point in time, we will try to look for a solution called as Ingress controller. Let's try and understand that. So let me pick up a fresh page. So I'll not go ahead and create a load balancer for each of the microservices. Rather, we would be going ahead and let me just draw the nodes and then I'll speak. My lines are not coming straight today. So these are the two nodes in which we would be drawing the pods. So pod A also needs external connectivity. Pod B also needs external connectivity. Pod C also needs external connectivity. Pod D also needs external connectivity. Then I need to create 4 different load balancers. A load balancer just for a load balancer just for B, a load balancer just for C application. Like that, it will go on and on, right? That is not the correct way of doing the implementation. Who would manage so many load balancers? So there is an application. How Nginx web server application is meant as a web application. SQL is a database application. There is another application which does the load balancing, which has intelligence of load balancing. It is called as Ingress controller type of application. Ingress controller. So Ingress controller type of application have intelligence of looking into the packet and then categorizing if you are trying to access application A, B, C, or D. It can open your packet and read it. So whether you are trying to access, say A is serving xyz.com, and if I have xyz.com/payments, it goes to B. C is for xyz.com/support. And D is xyz.com/say, I'm not getting a word for it. So say images, for example. Jack, it's not making sense, but I've just written it. So if you are trying to access xyz.com, I should route your packet to A. If you're trying to access xyz.com/payment, this is the application serving it. If I'm trying to access xyz.com/support, my packet should reach C pod. And if I'm trying to access xyz.com/images, it should reach port number D. So how do we do that? All packets would come to this Ingress controller. So Ingress Controller is also an application. It is running inside a pod. So if an application is running inside a pod and I need an external connectivity, what we do? We first create a service. Service for Ingress. And that would be of type load balancer. This will route you to your Ingress pod. Because you're creating load balancer type of service, that means you're getting a node port number. Say 30,879. And because you created load balancer type, a load balancer got created on the cloud. For which application? For Ingress application. The backend of it is this. And from there, it would reach you to the Ingress pod. So now whether your users are browsing xyz.com or your users are trying to browse xyz.com/payment or pay, or your users are trying to access xyz.com/support, anything out of it. All traffic, the green traffic, the blue traffic, say the black traffic, everything will get routed here. Black traffic will also go to the Ingress controller. Ingress controller is having a rule book like this. Okay, I've received a packet. I'll open the packet and see if the packet is for xyz.com. I'll send it to service A. If it is for like this, a rule book is there. It is called Ingress route. Ingress route. It's like a routing table. You receive the packet, you see where you have to route it. So you would forward the packet to service A. Service A knows how to transmit the packet to pod A. So packet is going to service A and from there it goes to pod A. Now, if it is a blue packet, packet comes in, it looks, and it would go ahead and match this particular rule. It would go ahead and route that to B. If a green packet is arriving, it would check this, it will go and match the support rule, and it would route the packet to the another nodes. This. How it will go to another node? Now understand, Ingress controller is a pod. A pod-to-pod communication within the cluster across host, which we learned, exactly same thing. When we were saying pod B is accessing pod A, how we communicated. Now Ingress controller is a pod for us. It is an application which needs to talk to pod C. That's it. So pod-to-pod communication across hosts, inter-host communication, whatever fundas we learn, everything would meet the same strategy would be followed, or same guidelines would be followed, and your packet would be transmitted to it. So this is how you route the packet using Ingress controller. Our responsibility to run an Ingress controller as an application in the cluster. I want this to be highly available application, so I'll run that as a kind deployment. Ingress controller would be running like any other application in the cluster, and I would create an Ingress route. It is called as kind Ingress. I would create that, and that would help me in having the rules. Where do I route my packet? When which packet arrives, what decision do you take for the routing? Let's see that. I think I'm here. Okay, cool. So let me clear up the screen. Okay. So I have a Ingress app1.yaml. I have a Ingress app2.yaml. I have an Ingress route.yaml. There are different YAML files which are there. Ingress app1 is just in a sample application. Ingress app2 is also a sample application. And Ingress route YAML file is the kind Ingress file. But before this, you've got to deploy a Ingress controller as well, right? So let me see. I don't remember the name of the file. Let me just figure out what is the name of the file. Okay, just give me 1 second. So we would have to deploy an Ingress controller. Ingress controller is an application which gets deployed. And that is just not a single deployment file which is needed to create it. I would have to create a service file, and there are a lot of things in the backend. So normally when we have a complicated application to be deployed, we can use something called as Helm charts to deploy it. Helm charts is nothing but a template which has all the data needed to deploy a stack, and using that we would be able to deploy that. So we would be using Helm chart to deploy our Ingress controller. So I'll first install Helm. I'm doing a wget and downloading Helm, and I'll go ahead and untar Helm app. So this is getting Helm into my node. It's not going ahead and doing any application installation. You can check which version of Helm you're using with Helm version. So Helm, you just moved it inside this user local bin. Now, we have not seen namespaces. We will just create a namespace this time. kubectl create namespace Ingress. And let's create all our related application within this namespace. So namespace is a way of segregating logical group of resources and keeping them under one boundary, so that you can put some limitations on resource level. You can put some limitations on the user level as well, who can do what in this namespace, that sort of thing. So I have created a namespace. Now I would go ahead and deploy my Nginx application into this namespace. And how would I do that? First, I'll go add my repo. So how a package has a repository from where you download the package, same way, Helm charts are also templates which you download from somewhere. So I am saying there is a repo link at this place. Go ahead and add that repo link with the name Ingress Nginx. Let's do that. This is added to your repository. Let me clear the screen and come from the top. Now, to install that template, command is helm install. To install the template, the command is helm install. Instead of doing all these things, I could have written some config map file, some say secret file, some deployment YAML file, service YAML file. There would be a bundle of files which I had to write, but I didn't do that. I'm picking up. I'm not the first person in this universe to set up a Ingress controller, right? People have done that. Suppose you want to set up a Jenkins master slave configuration in Kubernetes. Don't sit and write the YAML file from scratch. You can use a template which is already there. You just need to say helm install and install that template. So here, this is the template name. There are some parameters which I'm passing, name of the namespace. I'm saying that I'll create 2 replicas of it. And I'm saying create a NodePort type of service or LoadBalancer type of service, whichever type of service you want. Let's do it, LoadBalancer. So this will go ahead and create a deployment, replica set, pod, a service, some config maps, some secrets. A lot of things would get created at the backend, which we would not realize it. Okay, so it's an easier way of deploying an entire stack. So once this command has succeeded, you can check. You can see your secret is created. Some networking stuffs are created. You can go ahead and see whether this Helm install command has worked well. It would show that yes, this Helm template is installed. And from there, you get to know that template deployment has succeeded. Let's see all the resources which are running in Ingress namespace. 2 pods are running, 1 service is there, 1 deployment is there, 1 replica set is there, all came up by themselves. I just had a single template deployment, and it's just not this. There is config map, there is secrets, a lot of other stuffs are there. In kubectl get all type of resources doesn't show up. Okay, that's the reason you're not seeing them. Let me show you the application which we would create. I will go ahead and create a dummy application which we would expose only within the cluster. And then we would go ahead and deploy it and see, even if we don't have that application exposed outside the cluster, but using the application Ingress Controller, we would be able to access these applications from outside. So kind deployment is there. I'm running 1 replica of this application. This application's template is given over here. It's just hello world type of application, which will say welcome to Azure Kubernetes Service. And there is a service which is created. The name of the metadata is this. The specification says ClusterIP. This application is only exposed within the cluster. And I'm saying I'm selecting an app which would be having the label of this. So let me go ahead and create this application. And this application, I would create it inside my Ingress namespace. Okay, I'll go ahead and create that in Ingress namespace. So app 1 is created, a service and a deployment for it is created. Let me do kubectl get all in Ingress namespace. I should have this as well. This container creating message is there. Now let's see if you want to deploy the another application. This is another application. Application is of kind deployment here. And then I'm running 1 replica of it. This is also very similar, but the message which comes in would be different. It would say, welcome to, instead of Azure Kubernetes Service, it says Ingress Demo. That's the only difference. The welcome page is different as such. Here also, you are creating service of ClusterIP type, you can see. So this application is also not intended to be exposed outside the cluster. Let's go ahead and create it. Let's do a kubectl get all and list everything. Both the containers are creating, so we will leave it. We'll come and check in a while. So what all things are created? Let's see. This is created. This is created. This is created. I have created a load balancer type of service as well. And this rulebook is pending. This rulebook is pending, and that's the reason we will have to create something called as kind load balancer. Kind load balancer. Kind Ingress. Kind Ingress, not kind load balancer, my bad, kind Ingress. So if you create kind Ingress, it will be like a rule book for the Ingress controller. Let me show you the file. Okay, there is a typo. RESS, it is. Yeah. So I am saying that this is the metadata about it. Some annotations are there. Annotations are just for your information type of purpose, you can say. Rules are created here. It is HTTP rule. You can also create HTTPS rule. I have multiple paths as the backend. First backend is saying you will route the packet to service name AKS Hello World 1. When the path browsed by the user is this. Nothing is given, it's just slash and then a dot star. That means anyone just tries to reach the load balancer's IP address you go ahead and route that person to the first application. If someone is trying to access slash hello world 2, then you route it to this service. That is the meaning of it. So if someone is routing just load balancer's IP address like xyz.com, you are routing to first app. If you're going and accessing xyz.com slash something, which is specific as hello world 2, you get routed to hello world 2 application. So let's go ahead and create this. Let me clear the screen and create this. kubectl create -f. I would give the name of the file ingressroute.yaml, and I'll create that in Ingress namespace. So there is a warning coming in. From version to version, some of the extensions which are there, the name, the API version keeps updating. That has been the reason it has been specified as a warning. By the way, the resource is created. Let's go ahead and list everything. Pods are up and running. Things are looking fine. If you try to get Ingress is not getting listed in this. For Ingress, you will have to do Ingress. You can see here the Ingress is created and rulebook is there at the back end. So let me go ahead and see if the load balancer's IP address was there. I didn't notice that. Yeah, Ingress load balancer's IP address is there over here. So now we have created this rule book as well. We have just 2 rules in that rule book. Someone browsing xyz.com will go to service A, xyz.com slash hello world 2 will go to service B. That is what it is meant for. So I am waiting actually for a thing to get updated. Let's see. Address is not yet updated. This is still pending. The external IP address is yet not grabbed. Okay, why was that? I'll say kubectl edit svc and give the name of the svc. Hyphen and Ingress. So I'll change this type load balancer to type NodePort for now and see if we are able to access, because I think it's unable to connect to my cloud account and create a load balancer at present. So I'm just changing it to type NodePort. It's changed to type NodePort. I'll just clear it up. Fine, so things are looking good. I just need to fetch the NodePort number. Let me go to this. It says welcome to AKS. You can see this. And if I type /hello, it was a hyphen or it was not a hyphen. Let me look into the Ingress file once. hello-world-2 it is. So if I try to access this way, it will show me the other web page. So both the applications are reachable from outside, even though I have gone ahead and created our ClusterIP type of service for both of them. So these are the different ways of exposing your application, how does the packet gets routed and all that stuff. We have another session planned as well. There is another upcoming webinar too, in which we would be digging a little bit more deeper from security perspective and network security, what all things you can do. That is also there upcoming. So you can stay tuned for that as well. So yeah, so if we have any questions, we can post our questions in the chat and we will pick that up. So I'd like to take this opportunity. We will answer your question at the back end, that is certain, but we would like to take this opportunity to showcase our upcoming webinars as well. There is one webinar coming on MLOps, machine learning lifecycle. How do we automate the entire thing using Azure DevOps? That would be covered in that. It's on September 7th, same time. And there is another follow-up session of today's session, which is coming, in which we would be discussing about network, but it would be security with respect to network. It would be related to network policies. So these are the two upcoming webinars which we have. And there are upcoming trainings as well. As in the introduction, we mentioned that Tech Scalable is a training and a consulting company. We provide trainings. We are Microsoft Silver Learning Partners. We provide Azure trainings, but we also provide trainings across different clouds as well. We are starting our Google Associate Cloud Engineer track on October 2nd. We have CKA, which is Certified Kubernetes Administrator and Certified Kubernetes Advanced Developer session starting on the same day on October 7th. It would be a 10-weekend program. I would also like to show you what exactly we cover in our 8 weeks or 10 weeks program. What we do, CK and CKAD has a lot of overlap in the content. So we do 8-week CKA program, and those who have attended CKA, for them targeting CKAD is much easier. Like if you're targeting for an architect role, administrators and developers, both perspective, if you know that you have the knowledge of both the things, it would be a like cake, icing on the cake, right? So October 2nd, we would be starting a CKA batch. And then after 8 weeks, 2 weekends, we would spend for CKAD topics. And that would be like a top up on top of what we have learned for CKA. So normally we do a 8 weekends program, 4 hours per day we do. And in that, we try to cover everything with respect to breadth and length, everything. It's just not focused on your CKA certification or CKAD certification. We also prepare you for from the jobs perspective. Because a lot of people come with very minimal knowledge on containers, 1 weekend and a half day, like 8 hours plus 12 hours around, we take the time to teach you what exactly is containers, how it works and all that stuff. We teach you the connectivity between containers and all that, the Docker networking, which we were talking about today, that would go in deeper. And then finally, we start with our Kubernetes section. So we spend a good amount of time with microservices architecture and container basics. It might look like just 2 small bullet points over here, but it is 12 hours content which we cover in that. Then we have Kubernetes architecture, the core concepts, how does resources get created, what's the role and responsibility of each of the processes which are running, Kubernetes networking we do. Like today, you saw the flavor of it in 2 hours. You would be looking that in complete depth, what exactly DNS does, kubeproxy does, how they work, how is the DNS resolution happens, all those stuffs. And then how to deploy various applications in the cluster, real-time multi-container application stacks we would be deploying. Advanced techniques are there for scheduling. Today, we just left it to the scheduler to route our application to any of the nodes in the cluster. There are various scheduling algorithms which can be chosen. So that we go ahead and discuss about. We implement them. We talk about persistency of the storage. Containers don't have persistent storage, so you will have to mount a disk or rather, I would say, a volume inside the container. So the various ways of mounting it, that is there. How to do maintenance in your cluster. If you want to bring down a specific node in the cluster, you want to upgrade a specific node in the cluster, you want to upgrade the entire cluster, not operating system upgrade, Kubernetes upgrade you want to do. How security aspects are there, role-based access control, network policy, all those things we teach. Then we teach you about troubleshooting as well. Troubleshooting is very important when you're actually working on it. If some things are failing, you should be in a state to go ahead, analyze, and fix them. That we do. As I was stating, that from job perspective, also we cover a lot of stuff: daemon sets, stateful application, headless service. A lot of things are there which we cover, and we also talk about ELK stack, which is log aggregation stack, Elasticsearch, Logstash, Kibana, along with FileBeat. We cover that so that you get an end-to-end perspective, clarity about how things actually run in the cluster. And most of the time, when you're an administrator, you've got to monitor the cluster as well, the applications running in the cluster. So for logging and monitoring, this stack helps. We also have 2 sets of practice examination questions that we hand it over to you along with the solution so that you can go ahead and practice for the exam. It's a hands-on exam which you have. So we go ahead and give 2 sets of questions of around 19, 20 questions in each set. So we try to take you an extra mile. We cover init containers. We try to cover some real-world use cases, stateful applications, daemon set application. CKA is just about deployment type of controller, but we go beyond that. Because if you get back to work with just deployment controller, it will not make sense. You would not be able to handle a lot of applications. So we cover that so that you are ready for the job. We try to make you job ready in case you're planning to apply for any of the opportunities which are there in Kubernetes. You should be well equipped enough to do that, right? So I would be the instructor for the session. You had seen a flavor of my teaching today. So if you people like it and want to enroll for the session, you're welcome. So we have been doing training for long. We have a lot of success stories which are there. A lot of people post in LinkedIn saying that, hey, thanks, Mamta, TechScalable is really doing good and all that. So just a snippet of that to show that we have been quite successful in delivering sessions in a way that it makes things easier for them. And students grasp that so well that they don't have to become a robo, learn by heart the questions for the exam. No, we try to teach you in a way that you can utilize the knowledge and crack your questions. You get a certified administrator, you get a good hands-on level exercises. We don't go beyond maximum 25 participants. We try to keep in our batch. So our batch size is pretty small. We don't get herd of people and then try and impart speech. We don't do that because if it's a hands-on oriented session, we need to share the screens of the participant, give them ample time to do those exercises because it would be a hands-on exam as well. So in case you're interested to enroll to our program, let it be GCP course or any upcoming batches along with CKA or CKAD, whichever you would like, you can drop us an email or you can connect on this phone number and we can get back to you with the further details. So these were the few things I wanted to emphasize on because we do a lot of stuffs from job perspective. It's just not a bookish CKA exam which we conduct or training which we conduct so that you just get certified for CKA or CKAD. Our intention is never that. So that's all I have for today, I think. Team at the back end, I think we have answered almost all the questions. Hopefully we are good. So we will close the session with it. You can connect with us on LinkedIn. There is a page on LinkedIn for TechScalable. You can keep watching for our upcoming webinars, our upcoming sessions. We do a lot of posts related to our upcoming batches as well. So in case you're interested, do get in touch with us. And yeah, stay safe. And if any questions are there which I haven't answered, you can ping me directly on LinkedIn and I'll love to answer those questions as well. So that's all from our side today. Thanks team for attending and taking care at the back end. And thanks everyone for attending, taking out time and attending. Stay safe and take care. Bye.